Hi, grade 6. We're getting ready for our chapter 12 in math, fractions, decimals, ratios, and percents. This is a quick outline of what we're going to be able to do by the end of the unit a few weeks from now. Some of this is brand new, however, you have seen fractions numerous times before, especially decimals and percents. So you're going to relate all of them. That's here. So we're going to look at how they are similar, how they are different, and how they can work together. We're going to identify, model, and apply ratios in various situations. So you're going to see once again how ratios apply to fractions, decimals, and percents. You're going to model them in various types of pictures, number lines, fraction strips, so that you're able to make use of them in a visual way. Next, we're going to represent relationships using unit rate. Unit is another way of saying one. So 1 unit would be 1 of something. If you buy 15 items and you want to know how much 1 costs, that would be known as the unit rate. And lastly, of course, you're going to be solving problems using a guess and test. That will be using your inferring and your estimating capacity. We're going to move on. This right here is a fraction pyramid. We're going to be using this extensively. You may want to capture a screenshot of this so that you are able to make use of it on one of your devices. With this one here, you know how we've been talking a lot about what the 1 looks like. Whenever you start using a fraction, you must decide what the 1 is. In this fraction strip right here, this would be known as the 1. This blue strip with the 1 on it. This, for example, would also be a 1. This entire strip that goes down here. And you'll notice that this strip is broken down into 4 pieces. And that's how we get this as being 1/4 or 1/4. Once we define the 1, we can define every other fraction that we want. This, for example, is considered 1/6 right here. We know that's 1/6. This right here is considered 3/8. So this is 3/8. And we know that's 3/8 because there are 3 pieces here. But more importantly, this is where you have to focus. The 1, which is right here, has been cut into 8 equal pieces. And because it started off as 8 equal pieces, if we choose 3 of them, we know this is 3/8. Here I've put a number of them. I put a number of different fraction pyramids so that we can make use of these as we need them. As we need them, we'll take them and bring them to where we require them. Here is one of our review questions. What fraction of each whole is colored? So this is the whole right there. That whole thing would be 1. So now the question is asking what fraction of each whole is covered. The first thing would be how many pieces have we broken this into? This has been broken up into 12 different pieces. So 4 columns rather, and 3 rows. So we can start labeling this as a denominator of 12 because of the 12 smaller pieces inside the 1. And we can count 6 of the shaded pieces in. Those would be the colored pieces. However, there's also another way of looking at this. We could look at this as this entire piece is broken up into 2 smaller pieces. This would be 1 right here, and this is the other one right here. I'll highlight that for you. We have this right here. So that's our whole. And once I do this, here's one piece, here's the other piece. So we can also now say this is broken up into 2 equal pieces. And if it's broken up into 2 equal pieces, one of them is shaded. And we can say it's 1/2. And those of you who see other equal pieces here, you can see it also happens to be 3/6 and a number of other different pieces. And let's move on to B now. We can look at that as a total of 6 equal pieces altogether, and 2 of them are shaded in. This one, C, is one that is going to be very interesting to look at. So we know that this is 100 pieces all the way through. This is a 100 grid. So we know that one way of saying this is over 100 as our denominator. If we count these ones, there are 25 of them. However, you've also noticed we could see this as being broken up into 4 pieces. And if that's the case, we can say it's 1 over 4. So we have all these different ways of looking at it. Our next question, we're going to be comparing using a greater than sign, a less than sign, or an equal sign. Some of these are far easier to compare, whereas some of them are not as easy to compare. So if we look at the first one, A, we're in quarters. Our denominators are the same. That means that our whole has been broken up into the same number of pieces. Well, this one right here, 7 over 4, this is saying 7 pieces, and this is saying 3 pieces. So because our denominators are the same size pieces, we can say that this is greater than. 7/4 is greater than 3/4. If we looked at this as a picture, we could say 3/4 is right here. We're taking this 3/4. I've just circled 3/4. However, we need 7/4. So let's compare it to the one down here. We could say here is 4/4. That's 4/4. And over here is 3 more fourths. So visually, you can see that 7/4, 1, 2, 3, 4, 5, 6, 7/4 is bigger than 1, 2, 3/4. And that's helpful to look at. The next one is 2/5 and 4/10. So let's take a look at our work up here. We'll just erase a little bit of this. So if we go back to what our question's asking, it's 2/5 and 4/10. So we can go up here. If we look at 2/5, that's right here. This is our fifths, that's 2/5, compared to 4/10. Here is our tenths right there. Let's take 4 of them. And from the picture, you'll notice that they're the exact same size. So if I drop a line down here, the 2/5 and the 4/10 are exactly the same size. So for this one, we can say those are equal. Now 11/5 and 2/5. We can look at this one in the same way as saying our pieces are cut into the same size. They're both cut into 5 pieces. This one is 11 pieces, this one is 2. So this one is greater than. It's the same idea here, so we're both cut into 10 pieces. So 10 pieces for this one, 10 pieces for this one, 7 pieces greater than 4 pieces. For this one over here, this fraction here is less than 1. We know that 9 out of 10 pieces is less than the whole. We know this fraction is more than 1. This is 1 whole plus 1 over 10, and that's how we write it. So this one is larger. And this one over here, we're going to use our pyramid again, 6/12 and 1/4. So if we go back here, 6/12, we can take our 12ths right here. Here's our 6/12. That's 6/12, and 1/4 is right here. So we can see 6/12 is bigger than 1/4. So we can work on it that way. Now for decimal equivalent for each, show how you show your work. We have so many different ways of doing this. The way that we found out the decimal equivalent would be always writing it over 1, or writing as a fraction first and then writing it as 1. So let's write this as an equivalent fraction. If we write an equivalent fraction over 100, we could write it as a percentage. So if we multiply 5 by 20, we get 100. So 4 by 20 is going to be 80 over 100, like that, which is 0.8 or 8/10. We could have also done this one by writing 4/5 as a denominator of 10 and writing down 8/10. and we can write it down that way. So we can say 8/10 is a fraction, or 8/10 as a decimal. This one has already been done largely for us. We can say this one as 7/10, and if 7/10 is written in this way, we can write it as 0 ones and 7/10. Here we have 3½ which could be written down like this, 3½ right away, because we're saying it already as a half. This one is known as an improper fraction. So if we're doing the improper fraction, we can say that this is written as 5/2. So we can look at this one up here. So I'm going to erase all the ink. And if I take 5/2, I'm looking at this line right here. Here's 1/2, 2/2, 3/2, 4/2, 5/2. So once I mark off my 5/2, I can count my holes. This is 1 hole, 2 holes, 2½ holes. So I can come back to here, and we can write down 2½ holes. And now write an equivalent fraction for each. This is saying 73/100ths, so we can write it just the way we say it, 73/100ths. Same thing for 0.25. We can say this as 25/100ths, and we can write it like that. This is 6/10, so we can write it as 6/10, and we can say this as 1½ so we can cut that off over there. This one as 0.25, 25/100ths. This is similar to what we were seeing earlier on when we saw the 100 grid cut up into 25 smaller pieces. You can also write this one as 1/4.